and welcome to this year's Future City Experience. My name is Kim Bouffard, and I'm with Engineers Canada, one of 3 organizations who have come together to make this opportunity available to you today. Engineers Canada works on behalf of the provincial and territorial associations that regulate engineering practice and license the country's 300,000 engineers. We also serve as the national voice of engineering profession and are very proud of the work that we're doing to engage young people like yourselves, helping you to learn about all the fascinating and rewarding opportunities that you can pursue as an engineer. This is work that wouldn't be possible without the generous support of Natural Sciences and Engineering Research Council of Canada, or without our 2 fantastic partners, Engineers of Tomorrow, a national organization, a nonprofit organization that connects engineers with schools across Canada, and Ontario Tech University, an organization that is helping to train the next generation of engineers. But before we turn our eyes to space, I want to take a minute to acknowledge the lands that we are on today. I would like to begin by acknowledging the Indigenous peoples of all the lands that we are on today. While we meet today on a virtual platform, I would like to take a moment to acknowledge the importance of the lands we all call home. We do this to reaffirm our commitment and responsibility in improving relationships between nations and to improving our own understanding of local Indigenous peoples and their cultures. From coast to coast to coast, we acknowledge the ancestral and unceded territory of all the Inuit, Métis, and First Nation peoples that call this land home. Please join me in a moment of reflection to acknowledge the effects of residential schools and colonialism on Indigenous families and communities, and to consider how we can each, in our own way, try to move forward in a spirit of reconciliation and collaboration. Thank you. All right. You are all here today because you have accepted our challenge to try and design a city on the moon. This is no easy task. So to help get you started, we have sought out experts that are doing this work in real life, researching, testing, and designing ways to help us to build and live in space. To get you started thinking about this project, I'm going to pass you over to my colleague, Rebecca White, the CEO of Engineers of Tomorrow.
Thank you so much, Kim. And welcome everyone. I'm really excited to have you all here with all of us today. To get us kind of warmed up, I don't know where exactly everybody is joining us from, but it's pretty chilly where I am. So get us kind of warmed up and excited and practice a little bit with using our Slido program that we're going to use to collect all your very insightful questions today. I have a game that we wanted to play. So the game is called That's Me, and it's as simple as that. I'm going to share a few poll questions with all of you, and you're going to answer either that's me or that's not me. So if you are a teacher that is helping to facilitate this today, here's just a few bits of logistical advice for you. They're basically yes or no questions. So if your students are there present with you in the class, maybe just take a show of hands and pick majority. If maybe you have students that are joining you through a Google Meet, you could ask them or invite them to put their responses in the chat. And again, then pick the majority answer and then share that with us. So I'm going to share my screen with all of you so we can get going. Here we go. Okay, wow, everyone's already starting. So the first question, I've never met an engineer before. So is that you? Or maybe you do know some engineers. Share your poll responses with us, please. And while you're doing that, I'm going to take this opportunity to get you thinking a little bit and hopefully get you excited and maybe inspire some ideas for you for this challenge. So the picture that you are seeing up on the screen, that is actually one of the future city models that a group of students made for us last year. So some things for you to consider as you're looking at this picture. You might notice there's different kind of sections or areas in this model. And when you're thinking about your future city designs, I want you to get really curious and consider things like residential zones. Where are people going to live? What about commercial zones. Just like here on Earth, we're going to have the same patterns of behavior and habits. We're going to want to go and buy the stuff that we need to live every day. And so where will we do that? And then how will we get that stuff? Will it be manufactured on the moon? Will we have to import it from Earth? Like I said, I want you to get curious. So I'm looking at the results here. Very interesting. 81% of our participants today are saying, not me, I know an engineer or two. Wonderful. I am so excited to hear that so many people have met an engineer, maybe someone in your family or a close family friend. We typically see that engineering can be a bit of a stealth profession, engineers working behind the scenes, and you see all of the results of their work, but very often we hear from people that they actually have never met an engineer before. Oh, I see it's shifting slightly down. It's about 25, 75% there. So let's jump ahead to the next question. Here we go. I believe one day we might be able to actually live on another planet. Is that you? That's me. Can't wait to call the moon my home. I wonder what our postal codes would be on the moon. Or no way, I'd like to keep my feet firmly planted here on Earth. So as you ponder that, consider that, and share your answers with us. Let me get you thinking about this other very bright, beautiful design from one of our groups of students that participated with us last year. And some of the things I wanted to point out for you here, I see a big H in these blue buildings here, or representing buildings. So that's like a hospital. There's a police station here, a parking lot. So I want you to get curious and think about the different services that the the moon residents would need to have access to. How are they going to get educated? Where do they go to school? How do they get that training? How about healthcare? What about recreation too? We want to make sure that our moon residents are staying active and healthy. All kinds of things to consider when you really think about what is involved in the design of a city and the people that live in that city. Wow, very interesting. I'm looking here, 50-50 we're at for responses here, pretty much 50-50. Wow, I can't wait to see people actually living on the moon. And it sounds like we've got maybe some future astronauts here in the making as well. Definitely some future engineers in the making. All right, last question, because I know you all want to hear from our wonderful space experts here today. So here's my last question for all of you. Is this you? I am really worried about this project. I'm really worried that it's going to be hard. Is that you? Maybe you don't know where to start. Maybe it seems really hard, really complicated. Or are you like, no way, I've got this, bring it on. So as you reflect on that, I have this last picture to share with you. So for this last picture, I've chosen one again from last year's program. And this one was really interesting. I specifically chose this one because part of this program is taking your design ideas, your imagination, your questions, and taking those and turning them into real life. So you're building a model so that you can then share your design with other people. And in this case, we have a bit of a hybrid approach that happened. So this middle section of the image that you're seeing, this was a physical build. I think it looks like they used maybe like foam board or Bristol board or something with some maybe plastic bowls here to represent different segments and sections of the city. But then each section of the city was then they did like an expanded view here to show us in more detail what's happening in that section. And that part of the design was done online somehow. They may have used Tinkercad or another program to, again, help take their ideas and turn them into real life. And looking at our results, we've got a 50-50 even split, pretty close to even split for our feelings on how this program is and this challenge is being received. And I want you to know that is totally normal, and we are here to help you. So with that said, now we're going to have the opportunity to hear from some wonderful space experts who are here to help you and hopefully make you feel a little bit more comfortable and confident, because we've got you and we believe in you, and we're going to have a lot of fun over the next few months as we work through this program. So thank you so much, everyone, for playing That's Me. I'd now like to introduce Dr. Mark Rosen. Dr. Rosen is a professor here at Ontario Tech University. He is the founding dean of the Faculty of Engineering and Applied Science. He's also served as the president of the Engineering Institute of Canada and the Canadian Society for Mechanical Engineering. Dr. Rosen has worked all over the world, and he's passionate about sustainability and energy technology. He also has a background in aerospace and industrial engineering. So I'm sure he'll have some great insights for all of us here today. Thank you, Dr. Rosen. I will pass it over to you to get things started.
Hello, can I be heard and seen?
Yes, we can see and hear you now.
That's great. First of all, I have to apologize. My internet on my computer just died, so I'm on my phone. Apologies for the sudden switch, but I'm glad I made it in. Anyways, hello and welcome. It's great that I can be here with you. I'm really excited to do so. My name is Mark Rosen, as was just said, and I'm a professor of engineering at Ontario Tech University. Want to start first by issuing a welcome to all of you. And that's a welcome where I'm really glad to see that you're interested in something as exciting as the challenge that you've been asked to address, building a lunar city or designing a lunar city. Just amazing. I also want to rethank what's been done already, rethank the organizers, Engineers Canada, Engineers of Tomorrow, the Future Cities folks, and Ontario Tech University, of course. Today, basically, you all become engineers working to design a lunar city and all the supports that people will need there, supports they'll need to survive, supports they'll need even to thrive, maybe make it an exciting place. That's truly an exciting and awesome challenge. Perhaps it can also come across as daunting and overwhelming. It certainly does to me with my background as a dean of engineering, a chair of mechanical engineering. I was once director of aerospace engineering, all at universities. I'd find this terribly overwhelming. And with my years of experience in the energy engineering field and sustainability, it still strikes me as something, a challenge that is just overwhelming. So that's what today's about, hopefully to help make it a little less daunting, a little less overwhelming. Because this is engineering, and engineers take on challenges, whether they be great or small as, say, providing energy to drive all the fun things that we do here on Earth, to as large as building a city on another planet like the moon, or another celestial object like the moon. Engineers basically are problem solvers, and taking on challenges is what we often do. And that's what you're going to have to do. What technically is needed, what other constraints might apply, like safety or limitations on resources, all these things have to be dealt with. Engineers love working in such an environment where they have a challenge and constraints they have to operate in and yet make everything work. So in hopes of making this challenge less daunting, less overwhelming, and maybe to provide some inspiration, today we have a wonderful panel of scientists, engineers, explorers, inventors, and they're going to share some of their knowledge, their experiences, perhaps to give you some hints, to give you some inspiration as well regarding the challenge that you face. Now, before we hear from them, let me tell you a little bit about them. And after that, we're going to move on to hear a bit about the panelists from themselves. I want to tell you a bit about them first, and then we'll move on to questions. I know I've got some, and I'm sure you've got some, because I see on Slido question upon question rolling in. So let me introduce the panelists, as I said first. We've got three of them, amazing panelists, incredibly knowledgeable folks. I'm just overwhelmed in being able to introduce them. First, we have Marla Herring, who's a systems engineer working at MDA in Brampton, Ontario. She's worked on the Canadian team designing Spider, which is a type of robotic spacecraft that'll demonstrate the technologies needed to repair and extend satellites and their lifespans, pick up space junk, things like that. She's also been for a decade in the Air Force, the Royal Canadian Air Force, where she got to do exciting things like fly F-18 jets. She studied aerospace engineering and space systems design at Carleton University in Ottawa, to give her background to do all that. We've also got Dr. Cassandra Marion, who's a science advisor for the Canadian Aviation and Space Museum out in Ottawa. She's got a PhD in geology and planetary sciences and exploration, and that came from Western University, from their Institute of Earth and Space Exploration. She has done work focusing on meteorite impact craters, on lunar and Martian type analogs, the analogs being the Canadian Arctic, where if you see what an impact looks like there, you get a sense of what it might look like perhaps on the moon. And she's done simulation work for human missions designed to train astronauts for missions to Mars, missions to the moon. Finally, we have Matthew Bamsey, who's got a master's degree in aerospace engineering with a specialization in bioastronautics. I said it without missing it. From the University of Colorado, he got a PhD in environmental biology in Canada from Guelph, University of Guelph. He also spent 5 years at the German Aerospace Center, where he was a chief systems engineer for what is called Eden, part of the International Space Station. And that was a project to develop a greenhouse for the German Antarctic station, again, in an analog sense that allows 10 people to grow fresh food, test the technologies they would need, that astronauts would need for long duration space missions. At present, Matthew's at the Canadian Space Agency, where he's a senior engineer in space exploration, strategic planning. So as I said, three awesome folks, and I'm honored to be part of this. Now what I'd like to do is pass the floor over to them, because I haven't done justice to what they do. I think it's far better if you hear it from them in their own words than perhaps what got them into engineering. So let's let each of them give a bit of information about what they're doing. And let's see, why don't we start in the same order that I introduced? So let me turn to Marla first.
Hi, Mark. Thanks for that intro. So as Mark said, my name is Marla Haring. I originally grew up in Sudbury, Ontario, which anybody who grows up in Sudbury knows that Sudbury is actually a meteorite crater. And if you grow up in a meteorite crater, you grow up learning about space. One of my favorite memories of Sudbury too was going to Science North, and they had a model of the Canada arm there that was flown on shuttle. So I remember going there as a kid and being able to go and control it. And I'm like, wow, this is cool. I want to do something in space one day. There was a time when I was really little where I'm like, I want to be an astronaut, but then not everybody gets to be an astronaut. And I eventually went off to university, studied aerospace engineering in Ottawa, and learned a little bit about aircraft. You learn a little bit about space, and it was just really cool. So after university, I wanted a job where I could get exposure to different sorts of technology and get to see a little bit about Canada. And that's why I joined the Air Force. So I got to live all over the country. I got to live in Winnipeg, in Comox, BC, and then in Cold Lake, Alberta, where I got to do really cool jobs supporting test and evaluation on the F-18. So as an engineer, I got to work alongside the fighter pilots and test out new software or new equipment that we would fly on the F-18. And so while doing that, because we have several Canadian astronauts like Josh Kuchik and Jeremy Hansen, who are fighter pilots, I got to meet some of them because they would always come back to Cold Lake and do training. And they kind of got me thinking about my passion from when I was little, which is doing something with space. So thinking back to going to Science North and the Canada Arm, MDA is the company that built the Canada Arm. And you can see that on your $5 bill, actually. So it's something that's really important to space in Canada. And so I was lucky enough to be able to get a job there. So MDA does all sorts of really cool space robotics projects. So I got to work on one called Spider. And Spider was a tech demonstrator for NASA to show that it is possible to repair satellites that are in orbit and refuel them and fix them up so that they're not space junk. So it was really cool being part of a team to make that happen. And then now I'm going to be involved in some new robotics project. I just got back from maternity leave. So right now we have Canada Arm 3 being built for Lunar Gateway, which is a new space station that's being built around the moon right now. Well, it's being built on Earth, and then we got to send it up there eventually. And there's also something called Sample Fetch Rover, which is in support of the European Space Agency, and that's to go and explore the geology on Mars. So I'm really excited to be here today and share a little bit about engineering and what it's like actually working in Canada's space industry, particularly with robotics. So nice to be here, and I guess we're going to meet Cassandra next.
Thanks, Marla. Hi, everyone. So I'm Cass. Like Mark mentioned, I'm the science advisor at the Canada Aviation and Space Museum in Ottawa. But basically, my background is I'm a field geologist and a planetary scientist, which means I study rocks on Earth, but also on other rocky bodies like planets and moons like our moon. My particular expertise, as mentioned, is in meteorite impact craters like the one at Sudbury. But most of my field sites are actually in really remote areas. So in Arctic Canada and subarctic Canada. So Northern Labrador and on the high Arctic islands, where I get to go do massive expeditions and explore and collect rocks. But how did I get here? So I was interested, as I was growing up, I was interested in everything. I was an explorer, a sponge. I wanted to know how things worked, the why of everything. And I loved the outdoors, and I was doing well in science and math class. So I became a geologist. I went to school at first for geology, but I was always interested in space. I was a complete Trekkie growing up. That was my favorite show, but never really considered a career in the space industry because I didn't really know what was possible at the time. I grew up in a small town, and I was kind of in a bubble. Didn't really get much exposure to real scientists and engineers in my younger years. But after my undergrad in geology, I got this amazing opportunity to work on an impact crater in Northern Labrador that was set in rocks that are like the moon. They're called anorthosites. And just like the white part of the moon, an asteroid impacted there. And we call these sites that have environments that are similar to the moon analog sites. And so that I started specializing in these. And that particular research was funded by the Canadian Space Agency. And as a geologist, typically your funding doesn't come from space agencies, it comes from mining companies. And so that was something unique at the time. And then, from then on, I was hooked. I was into space and rocks at the same time. And I've kind of stayed on that train this whole time. And I started going to space conferences and participating in all of these mission simulations that were helping to develop technology and science to forward, to prepare us for real missions to the moon and Mars. It's time. So I got a job soon after that running moon missions out of Western University, and my salary was paid by the Canadian Space Agency again. So I was really fortunate sort of to land where I was at the time. Sometime after that, I got my PhD, and that led to my current position at the museum. So I was very fortunate to have so many wonderful experiences. When you're working with a wide range of people in these mission simulations, you get to work with engineers and doctors and psychologists, you just learn so much when you're working with so many different people. I'll share two, highlights recently. So the first was in 2019 when the Artemis program was announced. So Marla touched on this, the gateway the space station is going around, that's part of Artemis. We're sending people back to the moon to create a sustainable presence, and Canada is a huge part of that. We're going to be sending our astronauts to the moon, we're going to send rovers, and so much more. So after researching impact craters and doing all of these missions to prepare for the moon, now we're actually going to the moon, and so that was super exciting. And recently I got to participate in an Artemis workshop with NASA and share all of the lessons learned, that all of the work that we had done. We got to actually sit down and help them plan things. So which is a wonderful experience. And I'm now actually on the science team of one of the groups in Canada that is looking to send Canada's lunar rover to the moon by 2026. And then the second amazing experience I'd like to share is I've had the great privilege to train 3 different astronauts in field geology to prepare them for the moon. 2 of them are Canadians, actually both the same that Marla mentioned, Joshua Kutrick and Jeremy Hansen, and one Artemis NASA astronaut, Matthew Dominic. So just this past September, I took Josh and Matt up on an expedition to Northern Labrador to that same crater, the same first research site that had the moon-like rocks that really started my path in a space direction. So it kind of came full circle and developed I got to share my love for planetary science and help prepare real astronauts that may one day walk on the moon. So with that, I hope you're really enjoying this experience of both building a moon city, but also working together as a team towards a common goal. Scientists and engineers, we work together every day to make space exploration happen. And I wish you good fun and good luck. And I'll pass it over to Matt.
Great, thanks, Cass. And yeah, thanks, Mark, for the introduction. Wow, talk about passion. It's amazing to see Cassandra and Marla's passion and some of the interesting projects they've worked on. It's exciting. And although I didn't grow up in Sudbury like Marla, I can certainly relate to the Science North. What a place. I think any science museum or museum in Canada really, we got some exciting places to go to. So highly suggest that. It was interesting to see the poll results starting today, and just seeing a little bit of background about you guys, and also the fact that I think we all have full confidence in you in this upcoming project on the Future City. So come in with confidence, and it's going to be fun to go through a few things that hopefully can help you on your project today. But yeah, my background, as Mark mentioned, mainly an aerospace engineer. Always had the interest in my career to become an astronaut, like Cass and Marla mentioned. Got to go through a few recruitment processes in Canada. Pretty exciting. Learned a lot about myself, learned a lot of things. But at the same time, I also learned that the passion why I wanted to become an astronaut, from 1, to just to be able to explore, and 2, to be able to use some of this equipment that we actually take to space, was some of the main reasons why I wanted to become one. But I realized at the same time that engineers get to do that anyways. 1, the exploration side of things. So really to travel and explore new places. I mean, Cass mentioned that, and Marla moved across Canada and many different places. And I think as an engineer and scientist, you really get to do that. And I've been Very fortunate to do that. Also going to the high Canadian Arctic and Antarctica, as Mark mentioned. And even with those trips, had some run-ins with polar bears. We built a greenhouse to grow food and to learn eventually how we're going to grow food for our future astronauts on the moon and Mars in the high Canadian Arctic on an island called Devon Island, which is the largest uninhabited island in the world. And so we had webcam pictures from that greenhouse after we left each summer. And one day we picked up these big tracks on the webcam and we're wondering what that was. And we soon realized that a polar bear had decided to break into our greenhouse and disrupt our science experiment to grow food. The good thing is we're not going to have to deal with those, or you're not going to have to deal with polar bears in your future cities design on the moon. But they are things that we run into when we're testing some of those technologies before we'll bring them to space. And the other, interesting experience a few years ago was able to go to the German Antarctic station called Neumayer 3, which Mark mentioned. And again, using Earth, as Cass mentioned, also as a place to do science, to learn about space, but to also test some of the technologies that will one day send to space. And most of my career has been devoted to understanding how we can grow plants in these difficult places on Earth so that one day we can feed our astronauts on these missions, but also learn. For example, here in Canada, we have many remote communities in our north. And so the Canadian Space Agency, where I work now, we want to make sure that anything we do develop for space, we can use here on the Earth to benefit all of us in our day-to-day lives. And so if we can learn how to grow plants on the moon, hopefully some of that technology can help us in Northern Canada, for example. So as I said, for the last 3 years, I've been back in Canada working for the Canadian Space Agency. And really my current job is looking at what are the missions that are coming up for Canada in the future in space exploration. And one main focus, which is really, the excitement, and I'm looking forward to hearing about some of your ideas for your future cities on the moon, is really for my team to help us identify what could be Canada's next big contribution on the lunar surface in particular. And we're looking at things like robotics and rovers, like big power systems, maybe like a nuclear power plant, like greenhouse modules, for example, communication systems, and mining and what's called in situ resource utilization, or using resources on the moon, which you'll probably hear more about today. But I just want to wish you all luck in the projects, and all the stuff you guys are doing will certainly also be useful information for just hearing what Canada could do in the future on the moon. And so excited to speak with you about those over today. Thank you.
All right, thanks very much, Matt. Thanks also to Cass and Marla for giving those amazing explanations of what they've done and how they got where they are. It astounds me continually. Before we go ahead, an administrative detail that I should have mentioned first, but I forgot. Slido. Slido is intended for you to ask questions to our panelists. Not meant for a discussion board where you chit chat back and forth. We're trying to get good questions to relay in. So please use it for that, or it kind of becomes hard for us to sort out the questions from the general chat. Okay, we're going to move on to questions now, and I'm going to use the moderator's prerogative to ask questions first. I'll change the order up. I'll start with Cass first, for instance, with my first question. And it's as follows. Given that our future engineers, these students have taken on a monstrously huge challenge, that is designing a lunar city, providing examples of how their city will use 2 moon resources to keep their residents healthy and safe, which makes me wonder how they're going to design, what's going to be in, say, the souvenir shop. Is it going to be just moon rock, or are there going to be other things there? But with all that, they need to know, what is life like on the moon? What sort of resources are available to us? And I'll pass to you for that.
Thanks, Mark. So yeah, the moon is an amazing place. So I'll talk about sort of the moon in general. The moon it's really far away. It's 384,000 kilometers away. So it takes 3 to 4 days to get there to begin with. And the image behind me, you can see sort of what types of terrains are on the moon. The brighter material, we call those the lunar highlands. They're mountainous, ancient lunar crust, mountainous places made up of the ancient lunar crust. And then the darker splotches, those are mare. These are ancient lava flows, a bit younger than the highlands. And so, both regions are covered in thousands and thousands of impact craters. So, but in short, the moon is really not the ideal place for humans to live without the support of technology. So imagine you're standing on the moon. This is an Apollo image. This is what it looks like. There's no atmosphere, which means, so there's no air, which means there's also no clouds, no rain, no snow. And its surface is really, because there's no air, it means it's a very low pressure environment. And of course, no air means you can't breathe in that environment either. And so any astronauts that you put on the surface, they're going to need to be in pressurized either suits or habitats, and then the oxygen will have to be provided for them. The moon is a very dry place. There's no liquid water on the surface or underground as far as we know. There's no oceans. There's life. There's no life that we know of. There's also no food, right? Because there's no plants or animals that grow on the moon in this environment. And then the other thing, I want to have another little image here. There's also night and day on the moon. So the length of a day on the moon is about 14 days on the Earth, or 14 Earth days. And then that's followed by about 14 nights. So, the in sun, not so much in the sun. And that's, the case for most of the moon, particularly, closer to the equator, that there's these night and day. But in the poles, it's a very different story, because there are regions in the North Pole and the South Pole of the moon that get sun all the time, but the sun is very low on the horizon, so it's not as powerful, the radiation. Or if you're in if you're on a hill and the topographic high, you're going to get the sun all the time. But if you're in the bottom part of a crater, there are actually parts of the moons in these permanently shadowed areas that never see the sun. And so because of these areas where you get, during the day and during the night, there's a massive temperature range on the moon. Sometimes it's extremely hot to extremely cold. So it gets up to 123 degrees Celsius and down to minus 200 and 25 degrees Celsius. So that's a huge, huge range. And it can happen, between night and day, or if you're at the top of a hill or the bottom of a crater. There's also much weaker gravity on the moon. It's 1/6 Earth's. And the Apollo astronauts, they actually had to learn to sort of bunny hop around, or it was kind of like cross-country skiing with some oomph to avoid tumbling as they were trying to move around. So there's definitely some challenges there. And then the other sort of environmental thing is that there's no magnetic field to protect the moon from radiation. Earth has a very powerful magnetic field, and it protects us from most of the sun's rays. But on the moon, those hazardous rays could affect astronauts' health. And so that's definitely something that you need to think about and shield against. So I'm going to move on to the resources. What's there? If I go back to this little image, just to give you an idea. There's so many resources on the moon that can be used for a variety of reasons, for building materials, power, water, oxygen, and fuel. But I'm going to focus on 3 of those sources of resources. There's regolith, the sun, and water ice. And so depending on what your objectives are, you might need to, think hard about which of these resources suits your needs best. So the regolith, it's actually, you can see it in this image, it's a layer of this sandy, fragmented rock material that formed from years of impacts on the surface of the moon. Basically, the moon's surface got chewed up from impact after impact by asteroids and comets. And now there's sort of this layer of sand with chunks in it that are up to 10 meters in thickness at some points. But the best part of regolith is it covers mostly the whole moon, and so you can find it everywhere. These small particles of this regolith, we call that lunar dust. And these are actually they're like little shards of glass. They're super sharp and they're very sticky. They stick to everything. In the Apollo days, the lunar dust got stuck in instruments and it got into the astronaut suits and caused issues. So But the regolith and the dust are actually very rich in a variety of elements. So silicon, oxygen, iron, calcium, titanium, some rare earth elements or metals. And so there's all sorts of things that you could extract from the regolith. And each thing that you want to extract has its different challenges in terms of the mining processes. You could also use the regolith as a building material, just outright. You could form lunar concrete blocks out of it. This is things that, you know, some of the space agencies are actually working on doing with simulants today. And you can also, you know, process it to extract other things. And I did notice actually in the questions, but I was going to say this anyways, yes, you can actually use lunar dust, or at least we think, because we haven't actually tried it yet, to 3D print things. So that's another way that you could use that resource. Second resource, the sun. So as I said, during the lunar day, there's no clouds in the sky. Every day is a beautiful day, except for it only lasts 14 days. And then you have to survive another 14 days with no sun, unless you're at the poles where things are a little bit different, as I mentioned. So you can definitely use the sun for solar power. You could also use it for heat for things like sintering. So to construct those lunar concrete blocks, you're going to need to heat up the material to do so. And then the last resource I will mention, and of course I can't cover them all, is water ice. And so in those permanently shadowed regions in the poles, North Pole and the South Pole, but particularly concentrated in the South Pole, we've detected that there's water ice in these hidden areas from the sun. It's not, you know, you can't think of it as a glacier, because it's not going to be nice, pure, you know, very large amount of water ice. We're actually not sure how much is there, but it's probably a mixture of like 5 to 10% ice to 80-90% regolith. And so there's going to be some processing needed to remove clean water out of that. But water, of course, is going to be wonderful for drinking for your astronauts, but you can also break it down into its components, oxygen and hydrogen. Oxygen you could use for breathing and rocket fuel, and hydrogen you can use as another type of fuel. So I think I'll end it there and turn it over and back over to Mark.
Great, thanks very much, Cass. So now I'm gone from overwhelmed to really overwhelmed. Regardless, let's go ahead. I'm going to turn to Matt now, and got another question. Given what we heard from Cass, everything's really a little hard, maybe a lot harder to do on the moon or out in space. There are many things that make living on the moon challenging for humans, of course. Air, really hot or really cold at different times, very limited water from what we've heard. What tips might you have for students that will help them to protect future citizens of the moon?
Thanks, Mark. Yeah, that's a very good question. It's the moon is a harsh environment, as Cass said, and I think one other very important thing is this time when we're going back to the moon, this is going to be very international in nature. Many countries are coming together to work together. We've talked about the Apollo program before. That was a very United States driven program before. And in that time, there were 6 missions that landed on the moon, and only 12 people have walked on the moon before. The program that's happening now, and you've heard this word once in the presentation so far, is more focused on what's called sustainable presence. And this is where your cities come in terms of how can we stay on the moon in a way that is sustainable, in a way that we can do it over a long period of time and not make it so costly to go back and forth. And so this time, the process will be very much to start establishing and putting equipment down on the surface in these very early Artemis missions that you've heard about, and building things up very slowly. So one aspect that Cass talked about and that I'll jump into now is water. Water is actually a pretty heavy consumable, or something that people need. You know, what do we need to survive here on Earth as people? We need water, we need to breathe, so we need air. And we also need to eat. So let's jump into a couple of those things. And water is actually pretty, first of all, it's heavy, and we actually need quite a bit of it to survive. Not just to drink, but there's other reasons why we might need water as well for these longer missions. And in space, we certainly cannot use as much water as we do here on Earth. The average Canadian uses about 300 liters of water per day, which is a big number. And if you talk about even just sending, it costs about $10,000 to send 1 pound to the International Space Station, so just above the Earth. It's going to cost even more to send it to the moon. So if we're talking about $22,000 per kilogram to the space station, it's going to be very expensive to send water to the moon, for example. And so Cass mentioned one way that we can maybe get some water that's already there on the surface. But otherwise, we need to make sure we can recycle as much water as we can. And on the International Space Station, where astronauts go and typically live for 6 months and come back to Earth, they recycle about 90% of the water that they use. And so for your future cities, make sure we're trying to recycle as much water as possible so that we don't have to keep bringing it from Earth with us. And just as a fact, on the International Space Station, they recycle about 70% of the crew urine or pee. And unfortunately, when you're talking about sending people and humans in space, we got to talk about the waste products as well. We can't just talk about water, air, and food. We got to talk about the stuff that comes out of the astronauts as well. And you got to make sure you deal with that waste in your designs too. If we talk about food now, one way, obviously, like we do typically right now on space missions, is just to launch everything and send all the food pre-packaged with the astronauts. Well, I can tell you from experience, if you're living in a place and always eating the prepackaged foods over and over, things can get boring, for example. And as the missions get longer and longer, there's a lot of interest for us to start growing fresh food where the astronauts are actually living. So let's, if we're talking in this particular case about on the moon, you could imagine a greenhouse to actually have your astronauts be able to have fresh food with them as they stay longer. And again, that means you don't have to bring as much from Earth. The amazing thing that you could also consider about your greenhouse where you're growing food is that plants can also be used to help recycle water and air. On the air side, as you may know, we as humans, we breathe out what is called carbon dioxide. So every time we breathe out, it's a lot of carbon dioxide. And when we breathe in, what we use is oxygen mostly. And so trees or plants, when they are under sunlight, actually do the opposite. So they can produce oxygen that we need, and they can use the carbon dioxide that we breathe out. So that's amazing for not having to ship everything from Earth. So certainly consider how plants can help with recycling of air, food, and water as well, if you're imagining a greenhouse on the moon. And I think the other important element of actually having fresh food and plants is a psychological benefit. We don't want our astronauts or future explorers who are living on the moon to, we want them to be happy so they can go about doing their work all the time. One, it is for sure known, and many people use it as a hobby, gardening and playing with plants, and just also eating fresh food. So make sure in your designs you consider and think about how to keep the astronauts healthy as they live in your future cities. I think another important thing that you should think about in your designs, and it's very important for our space program now, is missions will be very international. As I said, it's probably, if we're talking about missions to the moon in the future, it's probably going to be made up. Every mission is probably going to be made up of a few countries. And so in your designs, for example, if you're talking about your greenhouse again, think about the plants that you might grow. It might just not be for an all Canadian crew. You might actually want to grow plants that other international astronauts and lunar citizens will also eat. And that you should think about in all of your design. How does having an international team affect your future lunar city? And finally, I think we hear all the time how exercise and being active can help keep us healthy. Well, on the International Space Station, where astronauts are living in microgravity, so like an environment where essentially they're floating around, their bones and their muscles do get weaker over time, especially if they don't exercise. So even in the schedule of an astronaut, typically they have 2 hours every day for them to be able to get ready, do their exercise, get cleaned up, and then get back to work or relaxation. And so even in your future lunar cities, even though there is more gravity, so about 1/6 the gravity that we have here on Earth, we're not yet sure what effects that will have on the body over the long term. And so in your future city designs, I think it's probably very important for you to also think about how exercise could be in the everyday schedule of those explorers who are living there, and what type of facilities or equipment you might need to keep your astronauts healthy, because we also want those people, as Cass does in her career, to get out into the field and explore and do science of the moon. And so for them to be able to do that, they also need to be physically fit. So exercise is an important element. So just as a recap, make sure you consider future missions to the moon are going to be very international in nature. Recycling of water is going to be important for sure, so that we don't have to transport it all from Earth. One option to produce food is to have a greenhouse and grow plants, for example, but they can also be used for air and water recycling, which is an important one. And I think exercise is something you want to consider in your future city designs, because it's very important in current missions with our current astronauts. So Mark, I'll hand it back over to you. Thanks very much.
Okay, thanks very much, Matt. Appreciate it. Lots of useful insights, tips, ideas that I'm sure will help our future engineers. I thought I could escape the gym, but alas, something they're going to have to work out there, and can't go to the moon to escape it. The energy engineer in me brings on some other thoughts and questions. I'm going to turn to Marla for this. Cities down here on Earth, we have an abundance of energy resources, a variety of types. Perhaps not so on the moon. Cities nonetheless require lots of energy in electricity and other forms to do things like power buildings, grow food, drive devices and machines, help us move around and transport whatever we need to move around, and communicate with each other. So my question, how can we do this? What technologies can we use to aid us in driving all these devices?
Hi. Yes, so energy in space is, well, if you're designing it, I would first look at how do we power our cities here on Earth? So, well, we don't have rivers, so we can't use hydroelectricity, but we do know that there are times when you will be in full sun. So you could use solar panels on, you could use solar panels on the moon. Another way it's been kind of studied for like deep space missions is using nuclear power. So actually in the Toronto area, there is nuclear power as a source of electricity here. And that is something that with your team, you could talk about it and find a way to do that, but be careful because there might be some safety concerns with using nuclear, and that might affect how you design your city. We've also used fuel in some parts of Canada. So some places used to burn coal and fossil fuels, but that is really kind of dirty. It's not sustainable. It makes greenhouse gases. But maybe there's a resource on the moon that could be used as a fuel, but maybe we can do it cleaner and do it better so that some of the problems that have been created on Earth won't happen elsewhere. So when you are designing your city, Cassandra talked about where we're going. Matt talked about some of the things that we need in our city, need to live, like water and air and food to eat and exercise. So now you get to engineer it and think about how do we make this happen? So yes, we need electricity to make this happen, but we also need machines to do that. We might need, so if we're talking about water, well, we might need a treatment facility, just like what we do on Earth. And we need electricity to power that. So I mentioned some ways to do that, but maybe we are going to get our water from the moon rock. Okay, well, how are you going to get the moon rocks? Maybe you also need a robotic system to go and collect the robot or the moon rocks for you. So when you are thinking about your city, it's very important to go through this thought process and break up your design into small parts and think about for each part, what do we need to make that happen, and brainstorm it and come up with some crazy ideas think about how we do it on Earth, but just make it better. I think that's what a lot of what we do in the space industry is we want to explore, we want to develop new technology that we can be using on Earth. And it's all about kind of being technically creative and trying to improve where we're at. So electricity, power, that's important. Nothing will run without it. I mentioned solar power is a way. Nuclear could be a way. Maybe you can think of a new fuel source that's sustainable, that has, maybe if there is a waste byproduct from burning it, maybe we can use that for something else to heat or, I don't know, to power another system. So yes, look at what you need, break it down into smaller pieces, and then from there, be creative and come up with something new. And I think, yeah, that's all I have to say on that. Over to you, Mark.
Thanks very much, Marla. Appreciate that. More useful information. But I'm sure, despite what we've heard from Cass, Matt, and Marla, there are other questions, and I know they've been coming in on Slido. So we want to use much of the remaining time that we have. We're scheduled to go to 1:30 to take questions from you and put them to our panelists and see if you can get some at least hints or answers to those questions. Now, for our organizers, I've got Slido up and I notice it looks like it reset at one point, so I don't see a lot of the questions that I saw earlier. Do we have those or not? Rebecca,
Hi,
you
Mark.
might know.
Hi, Mark. Yeah, Rebecca here. Sorry about that. I just reset it. There was just a lot of chat going on there. I mean, I am really excited to see all that energy coming through in Slido. But yes, as Mark mentioned, please use Slido just for the questions you would like our panelists to answer so that we can make sure that we get you those answers. But I did make a note of some of those questions that I was kind of filtering through the chat as you were all talking. And the first one that was kind of bubbling up to the top was more around the idea of taking these design ideas and turning them into reality. So there's questions from, for example, if we are maybe a group of students, they're part of a virtual school, how can we turn our ideas into reality? What sort of programs, like there are very specific questions. So what I'm wondering if maybe we could put out to our panelists is if you all put on your engineering hats, which would probably you're already wearing them, and maybe give some insights into how to bring these ideas to life for the students. What are some of the ways that and considerations as they're figuring out how to design their models? If you have some recommendations there, that seem to be the number one question. And then I'll start going through the rest as you maybe can respond to that.
All right, great. Well, thanks for that. So how to take these ideas and turn them into the results for the project that people are supposed to be doing here. Anyone want to jump in on that?
Like how the two aerospace engineers were the first to put their camera on. So Mark, you actually turned your camera on first, so you can talk first. Or,
no,
sorry,
I turned
Matt,
it on
Matt.
because I wanted to redirect.
Okay, I meant Matt.
Oh, okay.
Sure. Thanks, Martha. Thanks, Mark. No, I'll just say I think for this project, it's a great one because not everyone's going to have all the ideas. So really working together, brainstorming, like that brainstorming step in trying to solve a problem is so important because that is where we can get new ideas that really can make our designs so much better. So go seek input from your whole team and certainly come up with whatever ideas you have, brainstorm, keep the good ones, maybe get rid of a few other ones, but sometimes 2 ideas 1 + 1 will equal 3 in this case, where you get two ideas, they'll come together and they'll produce something even better for you. So Mark, back to you.
Anyone else want to weigh in on that?
Yeah,
Marla, I think you did.
I'm passionate about this because it's kind of my job. So as a systems engineer, our job is to take a crazy complicated system like a robotic arm and break it down into smaller components. So it always takes a huge team to make a complicated space system happen. And so the way we do it in real life is we will brainstorm, as Matt said, what is required? What is it that we're trying to do? And then after we've done that process, we'll go off and just in smaller teams, each team will get into the detailed design and figure out how are we going to do that? Do we need, I don't know, I'm just going to use the water example again. Like, do we need a treatment plant? So one group might go off and focus on the treatment plant, while another group might go off and focus on how do we power that treatment plant? And then we'll come back together again and share what we've done. So it's an iterative process. The other thing that's super important, and I actually mentored a team last year, is having somebody who's kind of keeping track of everything that you're trying to do and bringing the team together. So assigning someone who's kind of in the business world, the project manager, and just to be responsible for keeping your team on track is another way to break it up. The team I worked with last year, they were online the whole time, and they just got together on Zoom or had a like Google platform, like used Google Drives to just collaboratively type out their ideas. And this problem is something that anyone working in the space industry over the past 2 years has also been facing. We've all been online designing complicated systems from our basements or living rooms or kitchen tables. So it's tough, but it's totally doable if you have a strong team. So work together, break it up, and rely on your team and don't be afraid to ask questions.
Okay, great. So from Matt, we have 1 + 1 = 3. From Marla, we've learned you can design on your kitchen table. Cass, anything to add there, or do you want to move on to another question?
I think we can move on.
Okay, Rebecca, you said you'd look over that list again. Anything else?
Yes, absolutely. So I'm seeing some great questions streaming in now. So keep that up. You can upvote them if you want to, if you're interested in the same topic as someone else. But just to go back to the ones that I captured from before, there was a theme that was sort of emerging around transportation. So someone was asking, like, can we use rovers as vehicles? Can we use the gravity or lack thereof to our advantage when it comes to transportation? And there's some other transportation related questions I see in the current list on there too. So maybe some thoughts on considerations, I guess, for how we can move around on a lunar city or in a lunar city.
Yeah, my answer would be use a transporter like in Star Trek, but I don't think that's what you want to hear. So let me turn to our panelists. Any thoughts on transportation issues? Anybody want to jump in?
I like the transporter idea. Like, that's pretty cool.
Maybe a bit too, maybe when they get to grades 11 and 12, they can move on to that.
But yes, rovers, yes, that is something that's thing. You can actually Google. So Artemis is what NASA, that's the big NASA program to go back to the moon. And they have, if you just Google Artemis, and you'll find it on the NASA website, there is a diagram showing this new moon buggy rover that people are going to drive for the moon. There'll be some autonomous vehicles. I just don't want to give it away. You guys have to be creative and think about it. But yes to rovers, yes to transporters. I don't know, Matt, Cass, what excites you?
I'll just add one more to you, Marla. There's always one option with rovers too. Maybe some of the early rovers, the astronauts will be wearing their suits as they drive on those rovers, as the one Marla mentioned. But there's some pretty neat designs out there. For example, Toyota, we all know Toyota makes cars. Well, they are helping the Japanese aerospace center to develop a rover that's what's called a pressurized rover. So the astronauts can go in without their spacesuits and actually live in that rover for longer periods of time. So very neat stuff to think about depending on how far you got to drive away from your city.
Exactly. And I think I would just add that someone said, is it easier on the moon? And like I said, because there's no air, there's no friction. And so actually there will be, you won't need to use as much fuel to go the same distance in a sense. So there are advantages of having less gravity and no air for moving.
Yeah, and I guess if you have to carry things with less gravity, it's less of a challenge too. Okay, transportation. Rebecca, what else jumped out at you?
So the number one question at the moment. It's sort of a two-parter here. So some questions around materials that could be used to build houses or other buildings, I guess, that we would need to have available on the moon. And then part two of that is around more of the, taking care of our residents of the moon, or that are on the moon. So what sort of vitamins would we need to make sure that people are getting, or other things to make sure, I guess, our moon residents are staying healthy?
Interesting. Two parts. We can take them either part for our panelists. What will the houses be made of, or where do you get vitamins from? And what's one a day on the lunar day? Okay. Anyone want to?
Yeah, I can hit part one. I think Matt will totally take part two. So part one, what building materials? And I mentioned this, the main construction material you're gonna have to use is the regolith. And you can do a lot with it. You can change it in various ways. You can pull different metals out of it. As Marla mentioned, you're gonna need different machines and some energy to be able to extract some of these things. But you can set up a system as simple as using the heat from the sun to solidify that regolith into something solid, because right now it's very loose material, and you could sinter it to make sort of concrete blocks. So that's the simplest construction material you could use is making blocks out of the regolith, and then anything else you would have to pull. There would be some extraction process to take out of it, but all of the things, metals, a wide variety of material is available in that regolith. It's just a matter of pulling it out.
Yeah, I was going to plan on building a hobbit hole in the ground, but that's just me. Anyone else? In the vitamin part too.
Oh, I forgot. I'm going to add before it. Sorry. You could also use the terrain instead of necessarily building something up. There are regions on the moon that have lava tubes, for example. Instead of having to actually build the structure or build something, you could use an existing natural structure. Think of it as a cave to protect from the radiation of the sun, and build something into the existing terrain. Just something else to think about.
Great. I'm going to turn to Matt or Marla. If there's anything, Matt, vitamins, did you want to take a stab at that?
Sure, happy to jump in that one, Mark. I like the one about one vitamin every 14 days. Very good, very good. But yes, I think on the vitamin front, the good thing right now with the fact our astronauts are very well fed. There's a big team, for example, in Houston. There's also some folks at the Canadian Space Agency when it's a Canadian astronaut flying that really help plan the menu that the crew, that the astronauts are going to eat on their mission. And so they can be very selective in making sure that the astronauts eat healthy food. So more or less getting all the vitamins that they may need. So we shouldn't need too many vitamin pills. All of it should be coming in the way of the food that they eat. But we have to also remember that astronauts are not just going to want to eat spinach and broccoli all the time, right? Astronauts are going to need sometimes the luxury of eating something that, pizza. Unfortunately, there's no pizza plant, so we're not going to grow pizza, but we want to make sure that the astronauts definitely have access to things that will also keep them happy over time. But I think on the future, if we have a nice greenhouse on the lunar surface to grow food, we can make sure that the astronauts get all the nutrients that they need without needing to bring much else with them.
Awesome. Interesting too. Rebecca, let me turn back to you. Anything else on your list?
Yeah, so it looks like everyone now is starting to think about some of the challenges around what we've been talking about now for the last little while. And so there's the challenge that's kind of coming up here that a lot of people are interested in hearing your insights on is, what do we do when we don't have sun for 14 days?
Yeah, that's interesting. 14-day gap. Okay, so no sun. If we're relying on sun, what do we do for the 14 days when it's dark? Anyone want to jump at that? and I think there may be a sense even among our listeners, of course, well, we're going to probably have to store a lot of energy to last over that 14 days, whether it's battery storage or some other type of storage
To me,
of
what
energy.
comes to mind is living in northern Alberta, where it gets like really dark really early in the winter, and it's just really, really cold for 8 months of the year. And all I wanted to do was find sunlight and stay warm. So I feel like if I was on the moon and it was going to be 14 days, well, it's going to get really, really cold. So I need something to keep me warm. So I don't know. You guys have to design that. I'm not going to give you my answer, but you need a heat source, and I would go crazy being in the dark for 2 weeks. So I would need some sort of artificial light. I don't know. Cass and Matt, you guys have done some analog missions. Did you guys ever encounter this, or what's your thoughts?
I think, well, both Matt and I would say in the Arctic, usually we go up in the summer and it's actually 24-hour sunlight rather than the 24-hour nighttime. So we haven't had to deal with the dark, but what I will say is that, rovers right now that we're designing them to be able to survive the lunar night. And the first thing that technology needs is, as Marla said, is a little heater. And so basically the rover goes to sleep. Some of them, or at least the smaller ones, will be designed to just go to sleep during the lunar night, except for the only thing that they have to continue to power is that heater, because a lot of the instruments, are really not good with the frigid temperatures on the moon. So it'll be different though with astronauts. So I think I'll leave it to someone else to continue on with that.
There was a follow-up question that just kind of came in. I thought I would just flag it as you're talking this through around, are there seasons on the moon?
So Cass is shaking her head and no. So there you go. That answers on the seasons front. But if we're talking about Mars, there are seasons. So that's a super important question to ask. It's not just Earth that has seasons. I will, on the light question, maybe relate two items on that front. So relating it back to, again, a greenhouse to grow food, you can certainly consider your greenhouse to also have, it might use some light from the sun, but also using some artificial lights like many of the greenhouses now do, or what we call vertical farms, where we have, big buildings in downtown cities that have lights that actually grow the plants. And maybe on the question of the 14 days of darkness and 14 days of light, just remember also what Cass said about there are many places on the moon where, if depending on where you build your lunar city, that day length is much different. And at the South Pole, where most of the space agencies right now say that we should focus on, at least for where we're going to send our astronauts, there are places around there that almost have permanent sunlight, which will certainly help your city design if you are able to establish it at the South Pole, for example. Over to you, Mark.
Okay, great, thanks. And even if on the energy front for 14 days, even if you don't build at one of the poles, this is the same challenge we face on Earth when we use solar energy. It's available at times, it's not at others, and we develop storage. We can store electricity. We can store heat from the sun as well. At my university, we have an underground storage system. And my guess is you could do something similar on the moon if you wanted to get extravagant. But I'm getting ahead of myself there. Let's see what other questions we have.
Yeah, we have a new top question just popped up. Very interesting. What type of natural disasters should we prepare for on the moon? I really like the way people are thinking here, like engineers already thinking about how to minimize risk and keep our residents safe. So love to hear your thoughts on that.
Okay, besides space aliens attacking, what other disasters should we worry about?
I think there's number one that pops into my mind, but before I tell you what it is, just remember that most of the natural disasters on Earth are due to either geologic activity, things like volcanic eruptions, or hurricanes and storms. Those are all things that are generated when you have an atmosphere, and the moon doesn't have those. So we're not going to have mass floods or big storms. But what you can have is impacts by space rocks. And on Earth, because we have an atmosphere, all of this tiny space rocks, we actually are impacted by space rocks every single day on the smaller ones. But they just, think of a meteor, they burn up in the atmosphere. The vast majority of them they don't disrupt our lives and they won't cause a problem. Only the bigger ones, right? Which are far more rare. So on the moon, because there's no atmosphere, there's no barrier to stop those little things from happening. And so it gets impacted by micrometeorites, or meteorites from all different sizes. So the big disaster that is a potential event would be being impacted by a space rock.
All right. Anyone else want to jump in on that?
Maybe just
All right. So go ahead,
one more
Matt.
point. So sorry, Mark. Thanks. Just to hit on another point that Cass brought up before in terms of radiation protection, it just should also be remembered that our sun is very active as well. And so there can be what are called solar storms that can make that radiation environment worse or better depending on the day. And so just as you're designing your cities, just keep that in mind in terms of protection for your future astronauts as well.
Okay, so we need the sunlight, but we got to be careful about the sunlight when it gets a little too strong. Got it. And yeah, rocks and stones and meteorites, things impacting, yeah, they don't have the atmosphere to burn up on, so whatever enters the atmosphere will reach the ground, basically. Okay. Anything else jumping out at you, Rebecca?
Yeah, someone is asking, I think I saw a few other questions around the composition of regolith. So the specific question was, is there soil in regolith? But maybe you can just talk a little bit more about kind of the composition and give some more science around that, Cass.
Sure. All right. So we actually talk about regolith. We use the term lunar soil. But though we use the term soil, when you think of soil on Earth, it has organics in it, material that is broken down from, living things. And that is something that the moon doesn't have. We don't have organic soil. But the broken up sand in the regolith is made up of a variety of different minerals. There's a range of minerals. It does vary slightly from one spot to the other on the moon. But basically those minerals are rich in, the dominant elements that are in those minerals are silicon and oxygen. And then you add in some metals like iron, magnesium, titanium, and aluminum, as well as some other things like calcium. Not very rich in sodium, so you have to look for your salts elsewhere. But yeah, that's the main ones. And then there are some rarer elements and rare metals, as well as phosphorus, enriched in some regions of the moon as well, and potassium. Yeah.
Okay. Our regolith expert. Anyone else want to weigh in, or should we move to the next? Let's move to the next. Rebecca, what else is jumping off the screen at you?
Great. So there's a sort of a design choice type question that's showing up here. How many people would be going to the moon? So, I mean, obviously that is a design consideration when it comes to all the different choices you have to make. So I'm wondering maybe if the panelists can comment on the different things that would affect those design choices for number of residents.
Interesting. I can see that being interpreted in many ways, but I don't think it matters. Let the experts here interpret as they will. Anyone want to weigh in first? How many people? Or maybe is there a good number, a minimum number that a community would need to be able to operate?
Well, we're designing a city, and a city usually has a lot of people, like 100 people. I know, like in real life, like for Artemis, the first landing, they're only planning to send 4 people. And I don't remember if all 4 of them are actually going to set foot on the moon, but like right now when we're just exploring, it's less than 4 people, but we are thinking big here. We're designing a city. So maybe, I don't know, if you live in Toronto, let's make a plan to move all of Toronto to the moon. Or if you live in small town Northern Ontario, look at what your town in Northern Ontario needs and think of how you're going to relocate everybody there to the moon. I don't know, like, what do you think, Matt and Cass? I'm thinking big, like 100 people, or no, more than 100,000. That's Sudbury size. So,
Well, Marla, I think it's good. Think big, but I guess one fundamental question is, if you only have one doctor in your city
Mm.
who gets sick, who's going to help the other people? So always think about, do we have the expertise on one hand, the people with the right skills that your city is going to need, depending on what buildings are there? And do you have a backup? So similar thing when you were planning these smaller missions that Marla mentioned, we, even if there's only 4 people, we sort of want to make sure that two of those people are trained in all of the things that might have to happen during that mission. And as your city grows in size, you want to make sure you have the backup people there to support should things go wrong.
I don't have
Great.
much to add to that, but I would say that, we don't have the number in hand right now, how many would be on the moon eventually. So that's why we can't give it to you. But as Marla said, we're sending 4 first. And by about 2030, they're going to try and send the very first habitable, we'll call it laboratory on the moon, where we can actually go in and stay temporarily, but that'll be really small. And so the numbers will start small, but I think, again, I agree with Marla and Matt, that you should think sort of 100 plus, since it's a city.
Okay. Yeah, I'm just looking at some of them here too, knowing that time is running down. Is there enough gravity on the moon to hold structures in place? And I think the answer generally is yes. We see when the spacecraft they land, and there's no things like storms of hurricanes and winds that's going to tip anything over. But what else, Rebecca, do you see that's jumping at you?
Yeah, we sort of have a 3-way tie right now for top questions. So the gravity one you just covered. This one's really interesting, and maybe I'm not sure if we have maybe more biologist specific, but there's people wondering about, I think it's related to that 14 days of darkness that came up, but could we just go to sleep for 14 days and get through that dark? Maybe like your rover you were talking about, Cass's people, could we do that?
Well, let's hear what Cass has to say on that, or anyone else.
I can't speak, I'm not a biologist or any medical training, but I would think not. I can tell you that, right now, mission controllers that work on Martian time, which has a day that's extended just a little bit of time, you add an extra 40 minutes to your day, that actually really seriously changes how your body functions. And we are just not meant to go more than a couple of days without sleep. So you wouldn't be able to do the whole 14 days without sleep for sure. That's just my instinctual response.
Anyone else expert on sleep? I think that's a recipe for sleep disorders. No way I'm going to sleep for 14 days either. Okay, what else, Rebecca?
Yeah, I'm just keeping an eye on time there too, Mark. And
Yeah.
There's been quite a few questions coming up around sources of power. So how are we going to get the energy we need? I saw some questions around fire as well. Like, can we have fire on the moon? Or can we have an oxygen chamber that we could then use for fire? So just maybe some thoughts around sources of power or different sources of energy.
Okay, 2 things there, and in our limited time. Sources of energy, I guess we've talked about that somewhat too. Mainly the sun is going to be the key driver from the sound of it. Fire, can there be accidents where we have fire? And can we generate fire where we need it if we have to cook, for instance? Let me turn that one to the panel, given we only have 1 or 2 minutes left. Anybody want to jump on that?
Happy to start with some words on that one, Mark. Fire, I think, for space exploration missions is a very big concern, especially when we're sending astronauts in these very small capsules, which, as Marla and Cass said, the very first few missions that are going back to the moon are going to be in smaller vehicles. And one thing that engineers always have to debate or decide on in these vehicles is what makes up the air that is in these space vehicles. Because on one hand, you can have all of the air in the capsule just to be oxygen, and that would reduce the weight and mass of the vehicle that you're going to launch. But when you have only oxygen at a high concentration, that is a fire risk. And that is something that when space engineers design things, they look back into history because there has been a few accidents. Apollo 1 was a disaster that happened on the ground where there was a fire. So fire is a major concern, and for sure in your designs, please make sure you look at how you detect them and how you might be able to put them out.
Yeah, that's the first thing that jumped at me when I heard of fire, that, yeah, you can use fire, say for cooking, but boy, it's the concerns with fires that are the big problem, the disasters you can easily have, things that can get out of hand. I'm going to intervene at this point. We are basically out of time for questions. I know we have a lot more. We'd love to take them, but we end at 1:30, and I know that the organizers want to give a few comments. So I'm going to, at this point, pass it back to Kim for some final remarks.
Great, thanks, Mark. So yeah, I just want to thank everyone for joining us today. This is the kickoff of your big challenge that we put forward, and I think that, and I'm hoping that you got a lot out of the panel. I want to thank Marla, Cass, and Matt. You guys bring a wealth of knowledge to this, and have given these students an opportunity to actually meet people who are doing this work. So I'm hoping that not only are you inspired about, you know, tackling this project, but now maybe you're starting to think about how this project could just be the beginning. Maybe there's a career for you in the future in helping us to build off the research and the work that's happening on the moon right now. And who knows, maybe one of you might be one of those people who are on the moon helping us to figure out these sustainable cities. I also want to give a huge shout out and thank you to the other organizations that helped us. So this was brought to you thanks to Engineers Canada, that's the organization I work with, but also Ontario Tech University and Engineers of Tomorrow. So big thank you to all of them, and also to our main sponsor for this event, which is the Natural Sciences and Engineering Research Council of Canada. The next steps as we're moving forward is what's going to be happening now is that Rebecca is actually your go-to person when it comes to, now you're starting to try and build this and figure out all these interesting elements. So we have a variety of other resources that are available to you, and she'll be following up with all of you, making sure that you have access to those resources. And also to help you continue this journey, she's also been working really hard in helping to ensure that you have mentors that'll be available to you. And Marla mentioned that she's one of those mentors, that she's been out there helping classrooms and students get these things going. So that's going to be happening very shortly, where you guys will be paired with your mentor, and then you'll just start to, for the next couple of months, start thinking through this, you know, taking the advice of Matt and Cass and Marla to start brainstorming about what these things could look like. And the next step after you guys have built these things is that we're going to have a big showcase where it's an opportunity for you guys to actually take your designs and present them to a panel of engineers, where they'll give you feedback and let you know whether or not your city is ready to launch. So we're looking forward to seeing you in May when the showcase is, but in the interim, we have lots of support coming your way to help you as you design these projects. So thank you so much again. And I can't wait to see some of the great creative things that you guys come up with. So thanks so much. And thank you again to all our panelists. Really, really appreciate it. So bye, everybody.
Bye all, and thanks again.